Assalamualaikum warahmatullahi wabarakatuh. Good morning, good day everybody. My name is Saptamo from IPB University. I'd like to present our work about installation of sheet pipe subsurface system in Indonesia for effective drainage and improved soil aeration. This is the work togetherly being done by me, Mr. Yanuar, Mr. Husnul Arif, Mr. Budi Indrastiawan, Mr. Tamura, and also Mr. Matsuda from IPB University, Yamaguchi University, the Institution of Indonesian Engineers, and also Kyowa Kensetsu Kogyo from Japan. Okay. Nowadays, there's a need to increase drainage capacity of waterlogged farmland, which is experiencing decrease in production. The development of subsurface drainage technology and potential water saving by subsurface irrigation. By using the subsurface drainage technology can be a solution for this matter. The installation of sheet pipe system in Indonesia has been a significant development since 2017, and this collaborative effort between the Ministry of Agriculture and Japanese construction company has focused on enhancing water management in rice paddy. The system was installed in Sukabumi Rice Research Center in West Java with 7 parallel sheet pipes. Lines is measuring 116 meters length and with depth of 40 centimeters were laid out. These sheet pipe lines were consolidated into 3 drainage outlets regulated by valves. Then the primary objective of this work was to assess the drainage capacity and land drainage modulus, which is using the sheet pipe system. Sheet pipe is a long perforated plastic sheet shaped into pipes using special tools with pipe diameter 50 mm and pores diameter 2 mm. The function is to improve soil drainage capacity and with being beneficial for draining waterlogged soils and soil leaching. The standard installation of sheet pipe requires machinery like shown in these figures. And soon after we install the subsurface drainage system, we can control the condition of a water table in the soil better. So we can decrease the water table and get the better aeration for the field. So we did the measurement in sheet pipe subsurface drainage system at Rice Research Station. Now is Balai Besar Pengujian Standar Instrumen Padi, Sukamandi Subang, West Java, Indonesia. We measured the decrease of water level and also we analyzed the drainage capacity. This is the sheet pipe subsurface drainage system land at Rice Research Station, Sukamandi, Subang, West Java, Indonesia. Now it's known as Balai Besar Pengujian Standar Instrumen Padi. And also the layout of sheet pipe subsurface drainage system at Rice Research Station. We measured the flow rates by using gravimetric methods. And then we have this data as the results. The drainage rates after we analyze the decrease of water level for each outlet, which is represented by V1, 2, 3, which are the false codes, and we have the average and totals. If we put it into the graphics, we see this is the drainage rate that after we measured about 24 hours, then we can see the drainage rate decrease. And if we further calculate for the total drainage rate and the drainage rate per sheet pipe, we can see that the maximum drainage rate for each sheet pipe is about 1.2 liter per second. And if we accumulate the volume of drainage, then we can get the total drainage for 24 hours is 71.37. This research was facilitated by Center of Research in Engineering Application in Tropical Agriculture, or CREATA. So this table shows the reports to CREATA, which consists of parameters: drain discharge, drain rate, modulus, drainage, and drainage spacing. With discharge of 73.1 meter cubic per day and 3,600 meter square of area, water level can be decreased 20 millimeters per day. This is for free water. The time probable for aeration depends on the soil. Having 30% drainage pores, the system requires 1.5 days to decrease water table down to 10 centimeters. Further research for more affordable implementation design, lower cost, local materials, and non-mechanical option will be required. As for the conclusion, the result revealed the total drainage rates ranging from 0.396 liter per second to 1.431 liter per second. The maximum drainage rate per sheet pipe lanes was 0.2 liter per second. The drainage modulus was 275 meter cubic per day per hectares, and this demonstrates the potential of sheet pipe system in facilitating water level decrease to the sheet pipe depth and improving soil aeration. We thank Ministry of Agriculture, CREATA, and Kiowa for facilitating these works. Thank you very much.